This video is for section 8.1. I'm going to hopefully get this all into one video. So 8.1 is sequences and series. I'm actually going to skip over the learning targets and I'm going to go right to this definition. So a sequence, you can think of it just as a list of terms and they will have a pattern. The terms are listed like this. A sub 1 would be the first term. A sub 4 would be the fourth term. It's a finite sequence if it has an ending point. So if you were finding the terms from n equals 1 to n equals 4, you would be stopping at n equals 4, and that would be a finite sequence. That kind of covers this. Some of this, I already started writing some of this. So you probably will want to pause the video and fill some of this in. So it says find the first 4 terms of the sequence. So I'm just going to kind of walk you through the first term and then you should pause the video and write the rest of the terms. So if you're finding the first term, that means n equals 1. If n equals 1, I'm going to have a 1 here. So I'm finding a sub 1 and I'm going to put a 1 here. So I'm going to have 3 times 1 minus 2, which is equal to 1. So my a sub 1 will be 1. If n equals 2, I would have a 2 here and a 2 here. Substitute a 2 in there. 6 minus 2 is 4. So a sub 2 equals 4. So they're just asking me to list those terms. And here they are, 1, 4, 7, and 10. Notice they do have a pattern. They're increasing by 3 every time, which is where that 3 comes from. All right, the second one, just a different sequence, same process. If n equals 1, I'll have a 1 here and a 1 here. This is what it will look like when I put a 1 in here, which I didn't. So negative 1 to the 1 is just negative 1. So I would have 3 minus 1, so a sub 1 would be 2. If n equals 2, think of this. This is the same as negative 1 times negative 1, which would get me a positive 1. So I would have a sub 2 equals 4. If n equals 3, I would get a negative 1 again. So a sub 3 would equal 2. And then you can probably guess what a sub 4 would be. Negative 1 to a positive exponent, or to the 4th, would be 3 plus 1. So a sub 4 would equal 4. So my terms are 2, 4, 2, 4. Definitely can see the pattern in that one. Okay, example 2 is write the first 5 terms of the sequence. So again, if a was 1, I would have negative 1 to the 1 over 2 times 1 minus 1. So negative 1 to the 1 is negative 1. 2 minus 1 is 1. So my first term, or a sub 1, would be negative 1. A sub 2 would be negative 1 squared over 2 times 2 minus 1. Negative 1 times negative 1 is positive 1. 4 minus 1 is 3. So a sub 2 is 1/3. A sub 3, same thing. Negative 1 to the 3rd, that's going to be a negative 1. 2 times 3 minus 1 is 6 minus 1 is 5. So I have negative 1/5. And so on. I'm going to let you do this middle part yourself. Plug them in. A sub 4 is 1/7. And when n equals 5, I get negative 1/9. So these are my first 5 terms. Negative 1, 1/3, negative 1/5, 1/7, negative 1/9. So these terms alternate in signs. If you have alternating signs, you will always have this in your sequence. Negative 1 to the n is what gives you those alternating signs. Now the next one is a your turn. So this is what you are trying to write the first 4 terms of that sequence. Not sure if this is in your notes, but that is your answer. You definitely should pause the video and try that one and then check your answer. We're going to go on and look at example 3. So this says writing an expression for the terms. So this time they're giving us the terms and they're asking us to decide how to generate those terms. So write an expression for them. So the first thing you want to look for is some kind of pattern. Now, hopefully the pattern you're noticing here is that these terms are increasing by 2 every time. So if you're increasing by 2, your expression will have a 2n in it. So let's think if n is 1, I would have 2 times 1, I would have 2. If n is 2, I would have 2 times 3, I would have 6. So those are basically 1 more than all of these. So this is 2, I want 3. This is 5, I want 6. Or you can think, this gives me even numbers, I want odd. If I do 2n minus 1, let's try it. If n equals 1, I would have 2 times 1 minus 1, which would get me 1. If n equals 2, I would have 2 times 2 minus 1, which would get me 3. So a sub n equals 2n minus 1 is an expression that will get me those terms. So evens, going up by 2 is 2n. Going up by 2's, but starting with an odd would be 2n minus 1. All right, let's look at B here. So what are we doing here? This is plus 3. This is plus 5. This is plus 7. So if you look at the second difference, so first difference does not have a pattern. Check the second difference and see if you have a pattern. If I look at the second difference, I have a pattern. That is from, you can think of it like an x squared, like when we have a quadratic function. The second difference will be 2. So I'm thinking I'm going to have something with an n squared here because my second difference is 2. So I'm just going to do some checking. If n equals 1, obviously I would have 1 squared and my first term would be 1. I want my first term to be 2. So I'm going to say, well, what happens if I do n squared plus 1? If n equals 1, I would have 1 squared plus 1, I would have 2. If n equals 2, I would have 2 squared plus 1. 2 squared is 4, plus 1 is 5. If n equals 3, I would have 3 squared plus 1. 9 plus 1 is 10. So that would get me to 5, 10. So my expression is a sub n equals n squared plus 1. There is not a one rule works every time for these. They're all different, and you just have to do some investigating in order to be able to write those. The next is a couple of your turns. Definitely practice these, struggle through them, get them wrong, then figure out how to get them right. That's the best way to learn these. And you do have the answers for these right there, so check your work. And example 4 is what we call a recursive formula. So a recursive formula means that when you're writing the equation or the expression that represents the sequence, it's using the term before it. So recursive means uses previous term. So you'll notice they give you the first term, a sub 1 equals 3. And then they give you a general term. And see this? K minus 1, that means the term before. So we're going to use the term before, or maybe a better way to say it is previous term. use the previous term. So a sub 1 is 3. A sub 2, I think I'm going to put a 2 in here. So I'm going to have 2a to the k minus 1. So that would be a to the 2 minus 1, a sub 1 plus 1. A sub 1 is the previous term. So this is going to be 2 times 3 plus 1, or 7. A sub 3 is going to be 2 a sub k minus 1. So I'm going to put a 3 in here. So that's going to be a sub 2 plus 1. So a sub 2 is the previous term, which we said was 7. So this is going to be 2 times 7 plus 1, which would be 15. A sub 4, I'm just going to jump right to this, is going to be 2 times the previous term plus 1, 31. How many did they tell me to do? 5. A sub 5 is going to be 2 times the previous term, oops, sorry about that, plus 1, which equals 63. Okay, and then I forgot to mention this. We're starting, or we're saying that k must be greater than or equal to 2. Because if it's less than or equal to 2, you would get something here that doesn't make sense. So my terms are 3, 7, 15, 31, 63. And then we have a your turn, a recursive. So remember, recursive always uses the previous term. So try this one on your own, and what you should get is that. Okay, that is the first part of lesson 8.1.